Hello guys, today we'll be going with the 1999 Bulgarian National Math Olympiad Problem 1. So, the faces of a box with integer edge lengths are painted green. The box is partitioned into unit cubes. Find the dimensions of the box if the number of unit cubes with no green face is 1/3 of the total number of cubes. So let the side lengths of the box be A, B, and C. And without loss of generality, let A be less than or equal to B is less than or equal to C. So what this tells us is that we know that A has to be greater than 2, because if A is equal to 2, we have something like this, and obviously both sides are going to be faces, as seen here. All of these are going to be painted, and similarly for A equals 1. So A is always greater than 2. So now let's move this to the side. And now let's begin the condition in the problem states that there are A minus 2 times B minus 2 times C minus 2 uncolored squares, and all over ABC is equal to 1/3. Right off the bat, we notice that if A is equal to 7, the minimum possible value that this can take is going to be a 5/7 cubed, and this is 125/343, and this is already greater than 1/3. So what this tells us is that A is less than 7, because all the other cases will be greater than this value, and so that way they'll never achieve 1/3. So now let's test them case by case. So now we have A equals 3. If A equals 3, we have BC minus 2C minus 2B plus 4 over 3BC is equal to 1/3. And so multiplying 1/3 on both sides. No, sorry, multiplying 3 on both sides and multiplying BC over, we get that, and subtracting BC, we get that 2B plus 2C is equal to 4, or B plus C equals 2. And this is impossible because we know that B and C both have to be greater than or equal to 3. So A equals 3 yields no solutions. Now let's try A equals 4. If A equals 4, our equation is 2BC minus 2C minus 2B plus 4 all over 4BC is equal to 1/3. We can cross out the 2 and the 4 and yield another 2. And now we cross multiply, we get 3BC minus 6C minus 6B plus 12. And this is all equal to 2BC. So now we have BC minus 6C minus 6B plus 12 is equal to 0. Now we want to complete the rectangle, so we add 24 on both sides, and then now we can use Simon's favorite factoring trick to simplify this to B minus 6 times C minus 6 is equal to 24. We know that C minus 6 is always greater than or equal to B minus 6, and so then we can separate the divisors of 24 into 1 and 24, 2 and 12, 3 and 8, and 4 and 6. And so this gets us B equals 7, 8, 9, and 10, and C equals 30, 18, 14, and 12. And so now let's compute the volumes, because it's asking for the volumes. Since A equals 4, the volumes we have are 4 times 210, which is 840. 4 times 8 times 18, which is 18 times 8, what is that? 144. So 4 times that is going to be 576. 9 times 14. 9 times 14 is 140 minus 14, which is going to be 126. We have to multiply this by 4, so 504. And lastly, 480. So these are the volumes we get from A equals 4. Now we want to look at A equals 5. So let me just erase this. It's irrelevant now. Okay. So now let's look at A equals 5. If A equals 5, we get 3 times b minus 2 times c minus 2 all over 5bc is equal to 1/3. Now let's cross multiply. 9bc minus 18c minus 18b plus 36 is equal to 5bc. So 4bc minus 18c minus 18b plus 36 is equal to 0. 2b minus 9, 2c minus 9, and then this is all equal to 45 because you add 45 on both sides. And so what does this give us? This gives us similar logic to a equals 4, 145, 315, and 5 and 9. So b is equal to 5, 6 and 7, and c is equal to 27, 12, and 9. And so what are our volumes here? Since a is equal to 5, what's 27 times 5? 5, 5, 20, 35, 135. What's 135 times 5? 675. Now 6 times 12 times 5 is just going to be a 360. And 7 times 9, 63 times 5 is going to be 315. Now this is our last case, which is going to be a equals 6. So if a equals 6, we have 4 times bc minus 2b minus 2c plus 4 all over 6bc is equal to 1/3. Let's multiply 3 on both sides. So we get this is just equal to 1, 2bc, and now we can just divide again. So we get 2bc minus 4b minus 4c plus 8 is equal to bc. So bc minus 4b minus 4c plus 8 is equal to 0. Complete the rectangle. This is b minus 4 times c minus 4 is equal to 8. Same logic as before. We only have 1, 8, and 2 and 4. So this gives us b equals 5, c equals 12, or b equals 6, and c equals 8. Okay. The first case yields 360, and the second case yields 288. And now the problem is asking us to find the difference. Well, no, now the problem is asking us to find the dimension of the box. It's asking us to find the dimension of the box and the number of unit cubes. Known green face is 1/3. So these are all of our values. Thank you guys for watching.